Good afternoon, everyone. On behalf of agricultureinformation.com, I'd like to invite the speaker, Mr. S. Vijay Kumar, who will speak about how to do subsurface drip irrigation for sugarcane. I now request the speaker to begin. Thank you.
Thank you, madam, and thank you for giving this opportunity. I'm very happy with that. Agricultureinformation.com has given me so many opportunities, and today's topic for the farmers is subsurface drip irrigation for high efficiency of crops, and in particular, we are going to actually talk about sugarcane. So all of you should understand what is subsurface drip irrigation. The photographs and the sketch are self-explanatory. When you have the drip line which is going to be placed on the surface, then it is called subsurface drip irrigation. When the drip line is actually buried below the soil, then it is called subsurface drip irrigation. As you can see the photograph, the drip line is buried at a convenient depth or the required depth. So in this particular webinar, I will be covering the following topics. So first, I will be looking at what is subsurface drip irrigation. Second, I will look at what are the crops that are suitable for subsurface drip irrigation. Then we will look at the need and the advantage of subsurface drip irrigation. Then what is the typical layout of an SDI system, and what are the design considerations that are required. And finally, we have to look at the installation and maintenance part, which is again very critical to subsurface drip irrigation. So what is subsurface drip irrigation? That is the first question. The American Society of Agriculture Engineers very clearly defines what is subsurface drip irrigation. It is nothing but application of the water below the soil surface through the emitting devices with discharges almost as the same range as that of drip irrigation. Though today worldwide, it is a practice now to go for the low discharge in case of subsurface drip irrigation. Now, the second question that we have to ask ourselves is what are the crops and which are the areas where subsurface drip irrigation has been used? The crops mainly have been sugarcane and in protected cultivation, particularly greenhouses and shade nuts, and in certain places even for coffee and tea. And the countries, if you really look at subsurface drip irrigation, it has been in use for over 15-20 years in a very limited way. And we look at the countries that have adopted in large scale. It has been in Hawaii, in sugarcane, South Africa, Swaziland, Zimbabwe, USA, many countries. In India in particular, when you look at it, it became a necessity or mandatory, particularly in sugar factories that started adopting mechanized harvesting. That means when the tractor has to cane harvest the sugar cane, if the drip line is left on the surface, it could get damaged. So mechanized harvesting had to come in, and because of that mechanized harvesting, the sugar factories wanted the drip irrigation line to go below the surface. Particularly in Tamil Nadu, Maharashtra, Karnataka, and Andhra Pradesh, and also UP, many states have started adopting subsurface drip irrigation. Now let us understand the way the water moves in case of a subsurface drip irrigation and a surface drip irrigation. As you can see, in case of subsurface drip irrigation, the soil is getting distributed totally. This is actually an X-ray photograph where you are making out how the water is actually moving. And this is a surface drip irrigation and how the water is moving. So in subsurface drip irrigation, how is it different from surface irrigation? So what happens in surface drip irrigation, we all know the water flows basically by two methods. That is, one by the gravity effect and second is by the capillary action directly to the feeder root zone. Now in subsurface drip irrigation, since you have taken the drip line right to the place where the active root zone is, so it's going to be more that the water is going to be taken directly by capillary action and not much water is lost due to the gravity action. Here we'll have to keep in mind that we'll have to apply this in small regular intervals or pulses. That is a very important part that you have to take care over here. And it has been conducted over the studies. Subsurface drip irrigation will be as high as 95 to 97%. And for other places, it may be around 85 to 90%. For example, like when a person is admitted in a hospital, and it's like giving direct saline or drips to that patient directly. So that is the effectiveness. So there is no wastage at all. So even that small evaporation loss that happens on the soil surface is totally avoided, and the efficiency is as high as 95 to 97%. What is the need and advantages? Again, if we look at it, mainly we want to use the drip lateral for a long number of years. For example, perennial crops or crops in which ratoons are there. So in sugarcane and tea and many other crops, even certain places like maize, people have gone ahead for subsurface drip irrigation. And as I told you in the initial stage, that it facilitates mechanized harvesting so that the the drip laterals don't get damaged, because in the cultivation practices, the laterals could get damaged. Then we have an increased efficiency of irrigation and fertigation as high as 95 to 97%. And the crop quality is also very much good because there is a very much reduced fungal disease. You don't have any or very minimized fungal disease. Weed growth is totally eliminated because even that small water that is coming on the top will not be there. This is directly going into the root zone, and it is very suitable for intensive production, particularly increase in yield and increase in irrigation with fertigation. And we can have a very healthy, stronger root structure when we have a subsurface drip irrigation, and because the roots penetrate deeper and to the ground and they concentrate near the rather than concentrating onto the surface. So these are some of the need and advantages. Now, if you look at the schematic surface of a drip irrigation system, typically you have a water source, and here you will have to take care of all the safety devices that you have in a surface drip irrigation. I already conducted a session through agricultureinformation.com. You have to have the non-return valve. An important addition will be the addition of a flow meter, because we need to know how much quantity of water is getting into the system. Then we have the chemical injection system, which is definitely required for the application of water soluble fertilizers and also for the maintenance. And then we have the filtration, and then we come down to the main line and sub main line. The essential difference that come in here is that you are going to have a flush line or a drain line. At the end of the typical system of a surface, you will not have this flush line. Now you will have a PVC or a HDP flush line. And mind you, since the drip line is buried below the soil, you need to have sufficient number of air release cum vacuum breaker valves at required locations, which I will be speaking and showing you the diagrams also. Now let us look at the important design considerations when we are going to go for subsurface drip irrigation, particularly in sugarcane. So the main factors that we need to be considered for subsurface drip irrigation in sugarcane will be, what is the soil type? The soil types typically sandy, loam or clay soil. These are the typical soils that we know, and we should understand that it has been proved to be very successful, particularly in case of sandy and sandy loam, clay loam to a limited extent. And the active root zone depth of the crop, that is where we have to place the inline, that also is a very important thing. So now you're looking at the sketch and you have the cane sets over here. You have to place the drip line slightly above that so that you don't have, because there is a risk of any kind of root entering into the drip line. So that is one thing. So the active root zone of the crop will decide where you have to place the drip line. Then you will have to see what should be the maximum root spread of the cane. That is very important. And as I told you, the root intrusion in the drip line is one of the challenges that will be there. And also you could have the roots coiling over the drip tubing. These are certain challenges, and we will see how we can actually overcome. And this is sugarcane, as you all know, typically it is a 1.2 meter row to row or a 1.5 meter row to row spacing that is being promoted by all our farmers. So where to place the drip irrigation lines in case of sugarcane? So this is a sketch which clearly explains that this is the drip line, and we are going to place it at a level slightly higher than the active root zone, but it is almost close to that level. And typically for sugarcane, that is anywhere between 4 to 6 inches, maximum 8 inches, not more than that. So that is the diagrammatic representation. Then when we look at the design considerations, and again emphasizing that when we are doing subsurface drip irrigation, we need to have a proper filtration based on the water quality and the water source. So that is very critical. I have covered this in my earlier sessions on what kind of filter to select. The second will be the use of air release and vacuum breaker valves at the appropriate locations. If you don't have this, then you risk that when the system is switched off, you could have mud suction or you could have root intrusion. So this you will have to ensure that you have sufficient number of air release cum vacuum breaker valves. Then the filtration has to be perfect. You will have to take care of giving the adequate number of sand filters and disc filters in case of open water sources. And if you have a deep borewell, definitely you have to go for a hydrocyclone filter followed by a disc filter. So this filtration becomes the heart of the system, and this should not be compromised. And we will also, in addition to the acid injection, we will be doing this by the venturi. We also have an additional treatment that we have to take, which is called as the herbicide injection, which in order to prevent the root intrusion. So I will be talking more about this in the later slides. So here I am again diagrammatically showing you that which are the locations that you need to have. So you are going to have the air release cum vacuum breaker valves at the head control unit. Then you need to have it at the submains. Then as I told you, you have a collector submain, so you need to have it at the collector submains also. And any other important point in the field, for example, if there is a valley point or a ridge point, typically on the ridge points, you need to have the release cum vacuum breaker valves. So these are all the various locations in which we have to provide the air release cum vacuum breaker valves, and this is a very critical requirement. So the installation, the procedure of that is generally which is being followed by the farmers. You have to have a collector pipe at the end of the pipe. Typically, it could be a PVC or HDP line of 40 to 40 millimeter or 50 millimeters. Then the trench level of the collector pipe should be deeper than that of the trench, because we want the water and if any debris is collected to get on. So you will have to keep it slightly at a lower level so that all the debris gets collected in the bottom. Then, as I already emphasized, the air release cum vacuum breaker valves at the required locations. And here, mind you, since we are not going to physically see the drip lines are not visible, so they are going underneath. Therefore, we need to have appropriate pressure checking points both at the submain and the collector level. It's very simple. You just take a tube out, bend it, and then you can have a portable pressure gauge and check out the pressures. So pressure check points are very important. And also, when we do the designing of the system, as far as possible, try to keep shorter sections so that we will have efficient flushing and the water will keep getting circulated. It is also most important thing over here is to encourage the farmers to use water meters, because if there is a drop in the flow or if there is a drop in pressure, then immediately we will come to know that there is some problem with the system that is lying underneath the soil, which is not physically visible to us. And in case of inline emitter system, and if you are having the flat emitter system, the orifice typically should be facing the top and not the other way around, so that we avoid the roots searching and coming into the inlet of the emitter. So this is a typical sketch, diagrammatic sketch when we do the design. So you can see how that we have the main submain and then we have the drain submain, and we'll have to provide the air release cum vacuum breaker at the inlet of the submain and as well as at the drain part. So this is again just to emphasize that point. And when we come again into the installation, we have to follow a sequence. So what is the sequence? All of you know that from the submain, we will be taking a takeoff and a grommet. And from there, this is going to be at a certain depth. And from the depth, you are going to have the connection. Either you could have an elbow kind of a connection or you can have a T connection. And then if you're going to have the lateral on both the sides. And then when we will start initially with a 1 meter of blind tube or a plain lateral tube, after which we'll have a connector, and then we are going to have the inline drip irrigation tubing. And that is how the whole thing is done. And typically for subsurface drip irrigation, the most important part is the type of drip line tubing. The type of drip line tubing will have to be a dripper which is actually having a pressure compensation feature, which actually has got a diaphragm inside, and it has to have an anti-suction and a pressure compensating feature, so that will form a barrier, physical barrier for anything that will enter into the system. Then this is a typical layout of a drip irrigation system that we have installed. So you can see there is a water source. This is the main line. From the main line, you have the sub-main lines. Then it gets into the sub-main, and then you have the sub-main, and also you have the flushing manifold or the collector. So all these are different words that are used, and these are the typical blocks. And each block will be irrigated, and based on the irrigation design, the hydraulic design that is done, so the entire thing can be taken care. And SDI is also another very important thing, is you can also automate it. So you can have a subsurface drip irrigation wherein you will have the pump, you have the black flow implementer, then you have the flow meter, which I told you is very critical. Then you have the fertigation tank, which can be automated. Then you have the pressure gauge stations. Then the whole thing will be automated with the help of a controller. And as I told you, we need to keep pressures at definitely PC drip lines will require 1.5 bar at the inlet of the emitter itself. Therefore, the pressure required at the head control will be much higher, and we can have the system, and the whole thing can be automated, and with the help of the irrigation controller, the irrigation and the precise fertigation can be carried out. So this is diagrammatically how the farmers are doing it in the field. This is one of our fields, and you can see first we'll have the disc ploughing that is done, and then the field has to be leveled totally. And once the field has been leveled totally, then we have the row marking. So farmers typically use a PVC pipeline, and if the row spacing is 1.2 meters to 1 meters, you can have the marking very neatly done. And once the marking is done, then the submain has to be marked out. And once the submain is marked out, then the subsurface, after that, you will have the attachment to the tractor, and the subsurface drip irrigation lateral is laid out into the soil. I will show you that machine in the next slide. So this is the tractor attachment that is there, and the drip coil will be put on the coiler, then it passes through the tube, passes through the tube over here, and then directly at the required depth, the attachment will ensure that the drip lateral is laid at the required depth. So this is the thing. So field preparation and land preparation, all this has to be done. It has to be a level field, and then you can go about doing the entire laying of the subsurface drip irrigation laterals. And here I would just like to elaborate in a simple way what are all the steps. Generally, you select the maximum length of the field for lateral laying. Ensure that all stones and other big clods are removed totally. And if there are any stubbles of the previous crop, even that has to be totally removed. Prepare the field thoroughly with the disc plower and then finally with the rotavator, and make it in a level condition, and ensure that the depth of plowing is at least 1.5 to 2 feet below the after the rotavator is completed. For a light soil like sandy soil or a sandy loam, we'll use what is called as an extra winch lateral laying machine, which will ensure that the soil moves away and it doesn't fall into the furrow. So this you will actually, when during the installation, you can understand this. And always start the laying work in a straight end and lay the laterals along the entire length. And typically the submains are toward the end of the plot, and from the end of the plot the laterals are laid out, and you have to lay the mark and mark the trenches correctly. Adjust the hydraulics and the tractor so that the lateral release point is minimum 6 inches or 5 inches or the desired depth of the active root zone, and see that the lateral is laid down. Adjust the ridges so that the base is at least 4 inches down from the lateral, and in between the distance, the ridges should not exceed 1 foot. Do not lay the laterals when the field is very wet, because you know the tractor is going to totally disturb the whole thing. So, and also do not allow, once the field is laid out, do not allow the tractor to go in the opposite direction across the rows. And particularly when you're laying the lateral, there could be some challenges. Sometimes if the tractor speed is very fast or you're pulling it at a very thing, that it could get cut. So keep sufficient number of connectors and ensure that there are no curves or bends. The laterals have to be drawn out in a straight line, and ensure that the sufficient tension is kept at the laying point. So these things you will understand when you actually lay it out in the field. But I'm just telling you the important points that you have to keep in mind. Now we will come to the final aspect, that is the maintenance aspect of subsurface drip irrigation. So like surface drip irrigation, you will have to follow the acid treatment. I had covered the acid treatment earlier itself for you, and typically we will use dilute hydrochloric acid or phosphoric acid for the acid treatment, because we have a filtration system which takes care of the physical impurities, but the salts that are there in the water have to be periodically removed, and that can happen only with the help of acid treatment. Now, an additional treatment that comes in over here is an herbicide treatment. Either you can use pendimethalin or treflan. Treflan, I think, now is banned in India. This is basically you are going to prevent root intrusion into the drip line, because the orifices are there and the roots will come in search of water. So that area will actually be prevented by the help of this herbicide treatment. And typically the dosage is 0.125 ml of herbicide per emitter at the required concentration. I will even show you the calculation. So when do you apply this pendimethalin or the herbicide? Generally at the end of germination period, 3 weeks after the first irrigation, number one. Number two, second, at the end of the growth, 15 days before the harvest is recommended. And we'll generally inject it for a very short period of 5 to 10 minutes. And after injecting it, immediately you should not irrigate. You should irrigate only 24 hours. Otherwise, the chemical will get dispersed and the root will not, because it will get into the soil. So at least one treatment with herbicide is required at the beginning of the new ratoon crop. After you do that, then flushing of the laterals via the collector submains, you can do it once in 3 days. Then the regular maintenance procedures like cleaning the mesh filter, cleaning the disc filters, this has to be carried on. And sand filter cleaning based on the water quality and the organic load that is coming into the filter, that also has to be taken care. Checking of pressures is a very important part that is to be done over here. Any abnormal pressure variations clearly indicate that there is a blockage or a breakage, and we need to immediately rectify the blocked. So the pressure checkpoints, even permanent. I would even suggest you to have saddle connection with a permanent pressure gauges, but typically the pressure gauges will, if you want to have a longer life, you can have a simple connection and have a portable pressure gauge. Also, you will have to take care of the insect and rodent damages that may happen. But generally, we have found that when the drip irrigation lateral particularly is actually buried below the soil, the rodent damage is actually minimized. So that problem will not be there. But anyway, all these standard precautions have to be taken. So I want you to understand how this herbicide treatment works. So now you look at the sketch. This is the drip line. When you inject this pendimethalin or the herbicide, this will actually naturally get fixed in the soil And what it will do, it will not allow the roots. This area is going to be prevented from the roots entering into the orifice of the emitter. So this is how it is going to be working over. So you can understand how important it is. The herbicide will get fixed in the soil and form a root barrier. This is a very dilute concentration, so one need not worry about it. All farmers use herbicides for the removal of weeds. The same thing only is going to be injected, so that the emitter orifice will be totally protected. And these days you have even certain emitting systems which have a copper technology, or you have a technology. And with our product particularly, we have an anti-suction and a pressure compensating system. So even then, we would always recommend that you have to go for the periodical herbicide treatment. So just to get into the calculations, how much herbicide treatment, I told you it is 0.125 ml per emitter. And if the lateral spacing is 1.2 meters or 4 feet, and we know that in 1 acre or 0.4 hectares, the lateral length will be around 373 meters, and around 6,745 emitters will come in, assuming 0.5 meter spacing. That means roughly around 0.84 liters of pentamethylene will need to be injected. Similarly, if it is going to be a 1 hectare plot, it is going to be roughly around 2 liters. So the calculation is very simple. Just need to keep in mind this number of 0.125 ml per liter. And the products that we are providing from Premier Irrigation is that we have like I told you, the dripper, normal dripper will not have this silicon rubber, which is actually regulating, so pressure compensation. So discharges are kept totally uniform. And we have what is called as the inline cylindrical limit with PC with anti-siphon. The anti-suction valve will ensure that there is no suction of any particles into the system. Then we have a fine filtration system, and any particle that will even by chance gets in, that will also get filtered. And we have an extra large pressure compensating diaphragm, which will ensure that the discharges are kept uniform, and it will also be a physical root barrier for the drip irrigation system. And these are some installation photographs. You can see the farmer in Tamil Nadu actually is actually how he has laid out the cane, and you can see how the sets are actually being laid out. And then the next step, you can see how the subsurface drip irrigation has been laid out. The submains have all gotten, and farmers these days even use they don't want the kinking of the lateral, so you can have an elbow connection, and the submains are buried at a convenient depth, and the lateral lines are totally laid out. And this is the same plot after say 1.5 months after thing. You can see the germination is so uniform, and the whole crop, you can see the growth of the plants, and the drip lines are not there. See, the subsurface drip irrigation, the drip lines are below, in between these two rows, the drip line is underneath. And finally, this is one of our satisfied farmer in Tamil Nadu, and where we have given the entire system with the sand filter, because it's an open water source, with the help of a venturi injector, and then followed by a disc filter. And you can see the growth of the sugarcane, and the farmer was extremely happy. And also the farmer took a lot of effort in getting a good platform done, and ensuring that the whole thing is level. And this now is getting adopted, particularly in Tamil Nadu. They are giving an additional subsidy for farmers to actually go for subsurface drip irrigation. But keep in mind that all the precautions and all the things like acid treatment, herbicide, all these things have to be taken care of. So with this, I conclude my session, and thank you very much. And the session now is open for any kind of questions and interaction. So I will stop my sharing.
Yeah.
Yes, madam. Any questions are there? Definitely, I will take it up.
Mr. Vijay, for the detailed presentation. Now I'll take up some questions. Okay. So the first question is, what are the key benefits of using subsurface drip irrigation for sugarcane cultivation?
Yes, I already explained this in my slide. Anyway, I will again tell. So the main advantages that has been seen when we use subsurface drip irrigation for sugarcane has been that the water saving or the efficiency of the system is close to 95 to 97%. And with fertigation, the yield increase in sugarcane, which is normally yield is normally with 30 to 40 tons, has been obtained over 80 tons. So that is the kind of yield increase, almost a doubling, 100% increase in yield. So that is one thing fantastic. And like in the sugar factories, they want to have their uninterrupted cultivation of sugarcane. So you don't need to again remove the drip lines or anything. Everything is underneath and you just have to maintain it. So now farmers are moving into the next level of irrigation. That is, we call farmers welcome to the underground. The drip lines are getting into the underground.
Okay. And how does subsurface drip irrigation conserve water compared to traditional irrigation methods for sugarcane?
Yeah, in conventional method of drip irrigation, in method of just irrigation or flood irrigation, we are laying the water we are going to allow the water to move through the channels. So there is a lot of wastage of water. So that means if you take 1,000 liters of water, hardly about 300 liters of water is actually getting into the crop. All other remaining water is getting wasted in conveyance and water logging. So we are wasting water. So when we move into surface drip irrigation, the efficiency definitely goes up, and we are going to give it right at the root zone and not wasting the water in the conveyance or the percolation, and then the efficiency goes as high as 90%. When we take it to subsurface drip irrigation, that is even a step further. That means the drip line has gone below the soil, and the efficiency, it's like I told, that we are almost giving like drips to a patient. Directly we are injecting the saline directly at the place where it is required. And you must understand, sugar is a water guzzler crop and requires a lot of water. And by doing like this, it's the endeavor from the government that for water guzzling crops, particularly sugarcane, paddy, and wheat, we must adopt drip irrigation, and particularly surface or subsurface drip irrigation is the way forward.
Okay. And what are the recommended soil preparation techniques before installing a subsurface drip irrigation system for sugarcane?
Yeah, I think I showed a number of photographs and I showed you how the whole surface has to be kept level, and how the required depth it has to be done, and all the precautions. Ensure that you have the entire system laid out properly. Proper planning is very essential, and you can follow the steps that I had already very clearly explained, even both in stepwise as well as in the photograph. I have explained the entire thing. I think that will take care of the question.
Okay. And what are the important factors to consider when designing subsurface drip irrigation system for sugarcane?
Yeah, when we do a subsurface drip irrigation, the factors that we need to consider, most important factor will be the type of the drip irrigation system. You must go for a pressure compensated or a system which has got anti-siphon mechanism. That is number one. Number two, we have to see what is the type of the soil. And then also we'll have to ensure that it is not going to be a heavy clay soil. In heavy clay soil, it is not recommended. In sandy soil and sandy loam soil, it has been very successfully used by the farmers, but in very deep clay soils, it has not been very successful. This is one limitation of the thing. But otherwise, if you look at it, most 80-90% of the soils, you can definitely go for subsurface drip irrigation.
Okay. And what is the ideal spacing and depth for drip lines and this to set up this irrigation?
Yeah, that's a very good question. In fact, that is the most important part. Again, we'll have to ensure that the drip line is at a sufficient depth from the surface. So generally for sugarcane, the recommended depth is around 6 inches. So 4 to 6 inches, and depending on the active root zone, if it has got a deep rooted system like tea, you can go even up to 8 inches. So the crop root zone, active root zone, will decide what should be the ideal depth at which the drip line has to be placed.
Okay. And how can farmers and agri-entrepreneurs ensure proper maintenance of subsurface drip irrigation system for sugarcane?
Yeah, the maintenance is the most important part, because we can give a system and go away, and then the hand holding of the farmer on how to look after the system is the most critical part. From Premier Irrigation, we are offering Krishi Seva services, where whoever takes our drip system, we are going there and we will give them a kind of a service once in every 3 months, and they can enter into an annual maintenance contract with us, and we will continue to maintain the system for at least 3 years. Beyond 3 years, the farmer will get to know how to do it, and then he will start automatically doing it. So here it's only a question of educating the farmer and creating that awareness that these drip lines need to be maintained, particularly more so in subsurface drip irrigation. It's generally the farmers who already know about subsurface, they get into this because they want to get the additional benefit. And whatever standard practices of cleaning the filter or cleaning the flush valves or cleaning out the end lines, all the procedures which I had already explained in my earlier webinars, All that necessarily have to be followed. And air release cum vacuum breaker valve is a very critical component that has to be installed everywhere. And inspection and having pressure points everywhere and water meters, this will go a long way in safeguarding the system. Definitely a level of education. And we also conduct training programs for the sugar factory, the cane development officers, and also the farmers. We will call them and we take them to the field and we explain how exactly it has to be laid out and what are the maintenance, and hand holding for about 2 or 3 times, and how to go about the herbicide and the fertilizer injection. The farmers automatically learn. It's not a very difficult thing.
Okay. And how can farmers and agri entrepreneurs evaluate the feasibility and economic viability of adopting this type of irrigation?
Yes. So here what happens if a surface drip irrigation is going to cost you 1 lakh per hectare, a subsurface drip irrigation will definitely cost you 50% more. So this is one economical criteria. In certain states already they have started providing additional subsidy, like in Tamil Nadu, you get an additional subsidy. So farmers are encouraged to go for this. And the government of India is also envisaged on the vision of particularly providing micro irrigation for the water guzzling crops. So that way, all these subsidies will go a long way. And definitely in greenhouse and other things, people are already well aware of what has to be done. And then once you lay the system, the cost will get averaged over 10 years. So your drip line is going to last you longer. When the drip line is on the surface, it is exposed. So there is a sunlight effect that is totally avoided. So if the drip line normally lasts 5 years, this is going to definitely going to be 10 years. So you have to look at it not as a cost, but as an investment for about 10 years at least.
Okay. And are there any government subsidies or financial assistance for this type of for promoting this?
Yes, for the surface drip irrigation, currently it is there in most of the states. In 1 or 2 states like Tamil Nadu, you also have an additional subsidy or top-up subsidy for subsurface drip irrigation. And eventually, I think many more states also will give. Otherwise, the subsidy is definitely available and farmers are encouraged to go for it. And certain states are like Gujarat and Rajasthan, you will not even get a power connection if you don't have a drip irrigation system today. So that is the extent to which we have to be saving water and conserving water, because we know water is the most scarce resource today. And if you are not going to be careful about it, and looking at the monsoon scenario, and this is an El Nino year, and we have seen the way the climate is playing havoc, and the monsoon has got delayed by over a month. So all these techniques, micro irrigation techniques, will go a long way in helping the farmers and also helping the entire nation in water conservation.
Okay. And how does this impact the overall yield and quality of sugarcane crops?
The yield and the quality of the thing will definitely be very good, because you are going to fertigate, and the farmers are very happy with the kind of yield that they have developed. I told you, definitely you will get 30 to 50% increase in yield, and that will more than offset your cost. So if you actually do a return on investment, you're going to recover the cost of your system within 2 years, and farmers after that, it is going to be very good. So I think the yield increase and also the thing, the longevity of the system is really good.
Okay. And are there any specific fertigation or fertilization and or fertigation practices that need to be followed?
The standard package of practices advised by the agronomist of that area, which you are following for surface irrigation, can be adopted, except that keep in mind only water soluble fertilizers have to be adopted. For example, phosphoric acid can be given, potassium nitrate can be given, 19-ol can be given, urea can be given, but DAP cannot be given. Anything that is not water soluble cannot be given. So you will have to only take care. So whatever practices you are following on the surface drip irrigation, but here again, like I told you, the herbicide treatment will come in and the acid treatment will have to be done periodically every 3 months.
Okay. And what are the challenges and potential solutions in adopting this?
The challenges will be, first is the economy. Sorry. The economy part of it.
Whole question. What are the challenges and potential solutions in adopting this irrigation for sugarcane in different soil types?
Yeah, the main challenges that will come in is if it's a sandy or a sandy loam on the soil top, there's no problem. If it is going to be a very heavy clay soil, then I would not recommend. I would recommend you to go only for a surface drip irrigation. That is number one. And the since this is buried below the soil, the drip line needs to be slightly on the thicker side. So because you're going to have soil overburden, this is one thing you will have to take care of. And that way, there are we at Premier Irrigation will be very happy to guide the farmer. And there is a separate booklet. And if you visit our website, you will get all the information. Particularly, there is a full chapter dedicated to subsurface drip irrigation.
Okay. Now we have the last question. What financial and environmental advantages can individuals and agricultural departments expect from implementing this type of irrigation?
Yeah, it has been proved, and the last from 2003 onwards, from when the national mission started, and there has been saving in water, averaging from 10 to 40%. There has been saving in labor. There has been saving in fertilizer. All the advantages are there, and it's a proven technology. It's that how we are going to educate the farmer and how we are going to help him in the maintenance part. These are the two critical challenges that we are facing today. Is how do we ensure that these systems give their worth to the farmer, because government is spending so much of money. This money has to get utilized and it has to work for 5 years to 10 years. So the after sales and the maintenance part becomes the most critical part, and which is what we have to really emphasize, because farmers are now totally aware of irrigation system, particularly drip irrigation systems, but they need to be guided, and that is the main part will be on the after sales or the post sales and the maintenance part, and educating the farmer on the various advantages and encouraging him to not worry about the certain challenges like blockages and other things, for which now solutions and technologies available.
Okay. Yeah. And before we end, let me check with Mr. Anupam, who is available in Zoom. Mr. Anupam, you would like to ask any questions? You can unmute yourself. Yeah.
सर नमस्ते सर।
नमस्ते अनुपम जी, बोलिए।
जी कैसे हैं सर आप?
मैं ठीक हूँ, बोलिए।
सर अभी हमारे एरिया में नरसिंहपुर में काफी शुगर केन लगता है, मगर वहां पे हमने काफी किसानों से बोला कि सब सरफेस आप थोड़ा सा एरिया में लगा के देखिए, उसके फायदे काफी हैं। तो अभी तो ऐसा कुछ रिक्वायरमेंट है नहीं सर, भविष्य में जैसी भी रिक्वायरमेंट होगी हम आपको जरूर बताएंगे सर।
हाँ, ये स्टेज बाय स्टेज, बराबर
जी, आपकी हेल्प भी लेंगे सर इसमें।
डेफिनेटली ये स्टेज बाय स्टेज में करना पड़ेगा। अभी क्या है, लाइक यू स्टार्टेड फ्रॉम फ्लड यू मूव्ड इनटू ड्रिप इरिगेशन। अभी ड्रिप इरिगेशन से सबसे सरफेस करने के लिए पहले उसको ड्रिप इरिगेशन का पूरा एडवांटेजेस सब होने के बाद हम नेक्स्ट स्टेज, जैसे अभी मैच्योर्ड मार्केट है, डेवलपिंग मार्केट है और टोटली डेवलपिंग मार्केट, अंडर डेवलप्ड मार्केट है। तो एक एक स्टेज में फेस वाइज, जैसे अभी मैच्योर मार्केट में अब इसका अडेप्टेबिलिटी हो रहा है, और जैसे आपने बताया, जैसे आपके मार्केट में इसको काफी हमको डेमोन्स्ट्रेशन करके उनको सरफेस ड्रिप और सब सरफेस ड्रिप दोनों का क्या फर्क है ये दिखाने को, उनको बेनिफिट दिखाना चाहिए। अगर वो बेनिफिट दिखाएगा ऑटोमेटिकली वो अडॉप्ट करेगा।
थैंक यू सर।
थैंक यू, थैंक यू,
थैंक यू सर।
Okay, Mr. Vijay, I don't see any more questions from our participants. So now we have come to end of question round. On behalf of agricultureinformation.com, we like to thank you for a very detailed presentation and answering all the questions in depth. And we also like to thank all the participants for joining this meeting. The meeting will now be closed.
Thank you very much, madam. Thank you very much for agreeing.
Thank you sir.
Thank you.
Thank you.
Thank you.